Expanding a logarithmic expression, problem type 1. We've seen the properties of logarithms, can be used to rewrite multiplication, division, and exponents inside the argument of the logarithm as addition, subtraction, or multiplication outside the argument of the logarithm. And the reason this becomes useful is that every time you use this property, you go from something more complicated to something slightly less complicated. Right? Addition is less complicated than multiplication, subtraction is less complicated than division, and multiplication is less complicated than exponents. So by using these properties, we can expand things out and isolate the complication in a particular expression. All right, so I'm going to work with the common log base 10, just because I'm lazy and using log base 10 means I don't have to write a subscript, but this will work for any log. So let's consider the expression the log of x squared y over z cubed. There's a lot going on inside this argument. But working kind of from the outside in, the way we would solving an equation, the big thing going on here is this fraction bar, this division. So the first thing I'm going to do is split the log up over the division. Right, so it becomes log of x squared y minus log of z cubed. I've got some multiplication going on in here, so let's take care of that next. Right. Multiplication inside the argument turns into addition of the logarithms. So we'll split that up as log of x squared plus log of y, and then we're still subtracting log of z cubed. Then finally, I have an exponent here, I have an exponent here. Exponents inside the argument of a logarithm turn into multiplication outside the argument. So I'll take this x squared and pull it out front. So I get 2 log of x. Nothing really happens with the log of y. And then log of z cubed is going to be 3 times the log of z. And even though I still have 3 variables, and in fact now I have 3 logarithmic expressions in my, my work here, at this point, probably I can treat log x, log y, and log z as my variables, work from there, and then continue on with a result. One thing I want to remind you of is to be careful that subtraction distributes. In this case, I have the log of 7 over x times y. And splitting up that with the division is log 7 minus log xy. And then splitting up the multiplication here, multiplication turns into adding the logarithms. But this whole thing was being subtracted, so the whole thing that we replaced it with is being subtracted. And distributing that subtraction through, I end up with log of 7 minus log of x minus log of y. It's really easy to make a mistake with positive and negative when working with the properties of logarithms, so always pay attention and be careful with that.